Scientists just announced that the Large Hadron Collider found something for the first time ever. For centuries, scientists have been working hard to create and perform new experiments in order to invent or find something new. This is why the discovery of a new ghostly object by the Large Hadron Collider is so elusive. A neutrino is just a tiny fraction of the size of an ordinary atom traveled across the universe and finally clashing with the Antarctic ice sheet. Scientists located a neutrino detector within the ice to record the charged interaction of the neutrino, which resulted in a quick blue light flash. Let's take a look at this amazing new discovery. Large Hadron Collider. The Large Hadron Collider is the most powerful particle accelerator in the world. The Large Hadron Collider was developed by the European Organization for Nuclear Research and is located inside the 27-kilometer tunnel of the Large Electron-Positron Collider. The circular tunnel is 50 to 175 meters, which is roughly 165 to 575 feet underground and runs along the Swiss-French border. This might be just about a quarter of the information on this fantastic project, but stay tuned, there is much more to go. On September 10, 2008, the LHC performed its very first run. Isn't it exciting? Planning for the project started in 1984, and final approval was given in 1994. It took about 25 years to complete. The LHC was designed, planned, and built by thousands of scientists and engineers. For centuries, scientists have been working hard to create and perform new experiments in order to invent or find something new. What excites scientists the most is this discovery of something entirely new. This is why the discovery of a new ghostly object by the Large Hadron Collider is so elusive. It comes from a lot of centuries and a cost of nearly 5 billion materials and labor, which does not include the cost of running experiments and computers. The Large Hadron Collider has recently achieved a major milestone in quantum mechanics. New discovery. This is the first time that the ghostly particles have been captured by an earthly technology. The neutrinos continue to be a mystery because of their reluctance to interact with matter. The Large Hadron Collider at the CERN facility near Geneva, Switzerland, has produced neutrino candidates, which have finally been found by the International Forward Search Experiment team, led by physicists at the University of California, Irvine. According to physicists Jonathan Fang of the University of California, Irvine, the co-leader of the Phaser collaboration, no sign of neutrinos has ever been seen at a particle collider with the discovery of the ghost particle. It's now possible for scientists to find the origin of universe. The primitive particles have possibly changed with the course of time. It is still difficult for modern science to understand the history of the universe. Neutrinos are everywhere, all around us. Scientists claim that neurons are the most abundant particles in the world. They are one of the lightest of the roughly 24 subatomic particles that are known. The particles originated from the sun, exploding stars, and the Big Bang, which created the universe. They constantly, day and night, nearly at the speed of light, pass straight through the Earth. Our bodies receive about 100 trillion neutrinos per second. Ghost particles and their relationship with neutrinos. It is possible to see and difficult to detect neutrinos, which is a challenge for physicists. The instruments made to do this feel solid to the touch, but even stainless steel is mostly empty space to neutrinos, just like the solar system is to a comet. Additionally, because neutrinos, unlike most subatomic particles, are neutral in nature, hence their name, scientists are unable to capture them using electric or magnetic forces, as physicists refer to them as ghost particles. Even before the discovery of neutrinos, physicists imagined them. They developed the theory in 1930 to solve an unsolvable equation. The energy of the particles released when a radioactive atom nucleus splits must match the energy of the nucleus itself. However, researchers concluded that the nucleus was losing more energy than the detectors were detecting. So in order to explain this high-energy physicist, Wolfgang Pauli proposed that the nucleus might be emitting an additional invisible particle. As Pauli noted in his journal, "I have done something very bad today by proposing a particle which cannot be detected. It's something that theorists never do." How do you feel about this statement? Exclusivity of ghost particles. We are still unsure how exactly the universe was created. The ghost particle is one of the primitive particles that are said to have been created right after the Big Bang. They travel the universe at a lightning speed. Due to this, no one can stop them. A recent study showed that neutrinos, also known as ghost particles, can be 10 million times lighter than the mass of an electron. Because they are extremely vaporous in nature, cosmic particles can pass through any type of matter without changing it. Neutrinos are known as ghost particles. Scientists have now predicted the mass of the lightest type of neutrino due to the fact that they have almost no mass. Despite the most hostile environments, such as stars, planets, and entire galaxies, they can continue to exist. However, despite their immense energy, neutrinos lack charge. They are unaffected by magnetic fields of any strength.